Hey everyone, and welcome back to the channel. Today we are working on a Fujitsu Celsius H730 mobile workstation. The problem is the GPU. It's an Nvidia Quadro K1100M. And as you can see, when I power it on, we get artifacts on the screen. And after a few seconds, it just freezes or goes black. This is a classic sign of a bad GPU solder joint. The BGA balls underneath the chip have cracked, usually from years of thermal cycling. The chip heats up, cools down, heats up again, and eventually one of these tiny solder balls loses contact. No, the proper repair here would be to reball the chip, remove it completely, clean the pads, put new solder balls on, and reinstall it. Or, even better, replace the GPU with a new one. But on this laptop, the Quadro is soldered directly to the motherboard, and the replacement chip is hard to find and expensive. So today I'm going to try a reflow. I want to be honest with you upfront. This is not a permanent fix. Reflow can bring the chip back to life, but it might last only a few days, a few weeks, or if we are lucky, a few months. The underlying problem doesn't go away, but this is my own laptop. I use it for 3D modeling in SolidWorks, and right now is unusable, so it's worth a try. Let's get started. First, I am applying Amtech flux around the edges of the chip, so the flux can go underneath the chip with capillary action, and that's exactly where we want it. So all the solder balls can be clean from the oxidation when we apply heat. For this job, I'm using my hot air station with wide nozzle. I'll be using the wide nozzle the entire time, both for preheating the board and for the reflow itself. A wide nozzle gives you more even heat distribution, which is what we want on a big motherboard like this. A small concentrated nozzle can crack the chip and or damage components nearby. As you can see, I start with preheating the board. I keep my nozzle pretty far for the beginning because I want to heat up all the board evenly. So later on we can lower the nozzle right to the chip. If I just blast hot air onto the GPU without preheating, the temperature difference between chip and the surrounding board will cause stress. The board can warp and components nearby can pop off. So I'm moving my nozzle in small circles over the wide area around the GPU, and then as you can see I already moved a little bit closer to it. If you see that there isn't enough flux, you can still add more, because there can never be too much flux. As I am applying heat to the chip, you can see there are small bubbles forming from underneath the chip. That means the process is going well, and you want to see these bubbles. So continue applying heat for a few minutes, and then just take off all the heat and let it cool down. While the chip cools down, I start cleaning with isopropyl alcohol. It's 99% alcohol. I always start cleaning further away from the chip and work my way in. There are two reasons for that. First, the area further away is cooled down enough to touch, and second, this gives the chip itself more time to settle before I disrupt the area around it. You can see the burn flux is dissolving and lifting off of the board. So I will keep brushing and adding more isopropyl alcohol until the area around the chip looks clean. Any flux residue left behind can be slightly conductive and cause issues, so it's important to be thorough here. After everything is cleaned, I use a little bit of hot air so alcohol can evaporate faster and it's all dry. Okay, I put it partly together and let's see if it turns on. Because we don't have any guarantees that it will work or how long it will work. Well, at least it's trying to turn on, so it's good. I will test it and see how good the fix was, but I don't give any guarantees that it will work for a long time.